think it's going to be a really exciting talk. First, I just want to say thank you to Shape for hosting us tonight. And they provided all of the, obviously the space and all the food and drinks, so thank you very much. And I think Jason from Shape is going to say a few words.
Hey guys, thanks for coming. My name is Jason. I run our recruiting team here at Shape. I just want to kind of say hi and hello. And we are hiring across the company, especially our front-end team. I'm also open to just networking and chatting at the end when you get a minute. Thank you.
Great, so in a second I'm going to hand it to Matt. Matt's actually a core member of the Sentry project, which if you haven't used it before, is a tool, which you're going to learn all about, but basically allows you to, among other things, collect errors that are happening in your code and aggregate them and run some queries on them to figure out what's going on with your users. A use case I've used the tool for before, which is really helpful, is when I was developing a single-page web app. I could actually collect the exceptions that were being thrown in my users' browsers, and those would get sent up to a server, and then I can query against to see, what the heck is going on, right, on my users' machines. So, without further ado, let's give it up for Matt.
How's it going? Good. Awesome. So it's a little awkward because I've never actually used this Keynote application since you have to buy it for like $10 now. So bear with me. So also, I gave this talk at JSConf earlier this year. Since it's a little bit more formal setting, I definitely expect this to be a little bit longer because I will definitely answer questions as we go. Just kind of go through it. Anytime a question comes up, just raise your hand, and I will gladly answer things as we go. So this topic's really near and dear to me. Everybody writes really, really bad code. That's just a given. We do this. We're engineers. We write things, and things are broken. We ship this broken code, we deploy it to production, our users are complaining. This is just the nature of how things work. We really want to mitigate this, but as a fact, this is how it happens. So my name is Matt Robenolt. That is a lifelike representation of me. I am the lead operations engineer at Disqus. So what this means is I don't write JavaScript at all for my job. What I do write JavaScript for is for this project called Sentry, as was introduced. So Sentry is basically all around capturing exceptions. This is a Django application that runs as a server, and then the clients speak to it. So, for example, one of the clients is a JavaScript client. There's Python clients for Ruby, but whatever. So I kind of want to start this off with kind of a little a question here. If an exception happens in production, nobody sees the Chrome debug thing. Did it actually happen? So I kind of want to start this off. So who actually writes JavaScript and gets paid to do this? Awesome. How many people have written code and then shipped it to production and then went home to find out tomorrow that people were complaining that it was broken? And it worked for you. I do this all the time. So this kind of brings me to post-mortem debugging. So this is kind of an inevitable thing that's going to happen. We're going to write bad code. We're human, we're going to have errors, we're going to miss something, we're going to not expect what a user is going to do, and something's going to be broken. So ideally in these scenarios, we want to kind of understand what these happen before users complain to us. We want to know when we ship something that this bug that happened in Firefox version 29 is happening to, you want to know when this is happening because you're running on your local machine, some Chrome thing, and it, worked just fine. So humans are actually really bad at writing tests. So we kind of come up with this idea of writing tests and dealing with all these scenarios, but tests will literally never cover anything. We're even fortunate if our tests actually work at all, or we even write our tests. A lot of times we ship code that is not tested. QA processes are faulty. So human error. We have to go through and try to probe and poke and touch things, when in reality, we're not users. We may be users of a product, but we're not the users that we're targeting. Users tend to be not the smartest people in the world, if we have not noticed this. So users do things that you don't expect. A user is going to enter in their name a number. A user is going to enter in for their age the word, I don't know, anything. So these are things that we know we won't detect in QA. So no matter what we do, our bugs are going to get into production, so we have to learn how to deal with this. Who has seen this? So we get an issue report, somebody just says, it doesn't work for me. Someone's irate, your site doesn't work, something's wrong, it doesn't work for me, and you have no idea what's wrong. you're going to turn around and say, well, it works for me, so I'm not fixing this. User error, something's wrong, I have no idea. So what I'm kind of pointing at the bottom is the Chrome debug toolbar. So you have, if in an ideal scenario, you would get a screenshot of something saying, here's the actual error that I saw. This is the ideal scenario, but usually users are not that tech savvy to take a screenshot and send this to you. Sometimes you're fortunate, but most of the time, more often you're not. So what we do to be more proactive about this? We should capture our errors and log as much information as we can automatically. So we don't have to rely on someone reporting things, we don't have to rely on somebody telling us that it's broken. We'll know that it's broken by the chance that somebody actually caused an error. So we'll start with this thing, window.onError. Who is familiar with window.onError? At least the concept of window.onError. So this is my favorite thing. I also like to call this window.onNope. Because this is literally the most useless way of capturing an error possible. Literally the worst way of capturing an exception possible. So we kind of look at, if you're not familiar, it just accepts a callback. It's a global window.onError object. It accepts one function as a callback. It takes 3 arguments, the message, URL, and a line number. But in reality, what this devolves into is typically script error. I'll explain that in a minute. Kind of the problem with all of this is that we have these pieces of metadata that are not actually real errors. They are just strings that are telling us something about this error that we can't introspect for more data. So what actually looks like is you're going to get something like this. You're going to see the message is type error, cannot read property foo of undefined, URL, some file, and line number 10. Sounds really, really great, really useful information. But your code's probably actually minified. Line 1 is your entire application. And your JavaScript is being hosted probably on another domain, or a CDN or something like that for extra performance. So if your script is on another domain, why that's important is because you're subject to CORS. Ben, tell me what CORS is, because I messed this up last time. Cross-origin resource sharing?
Yeah.
Boom. I messed it up once, won't ever forget it. So what this means is when your JavaScript is hosted on a CDN, there are security reasons why another script cannot access errors that are triggered from these other third-party scripts. So if you include your script off of Cloudflare, and the exception is raised, what you actually get in window.onError is literally the string script error. Line 0, nothing else to go with it. So basically, there's nothing you can do with this information. Literally throw it away. So you have no idea what happens. So what's happening is it's kind of in the newer engines, and Firefox started. Firefox actually led this, I believe, and they started pushing out that you can send. It takes extra arguments to the callback. So there's an extra line or column number and an actual error object that's sent with it. So we have more information. So we don't have just line 1. We also have line 1 column 20,000. And we also get an actual error object that we can introspect. So why are we looking for error objects? What's so special about an error object as opposed to a window.onError? So we can get a stack trace from an error. So instead of it just saying type error or something is undefined, we can actually see the stack trace. Where did this come from? What was the flow of the code that happened to get us to that point? If you're lucky, because not every browser gives you all of that great information. So the stack trace is a record of function calls until now. So up until the point that the exception happened, it's a stack of all the function calls that occurred. So it's a little weird in JavaScript because we have all these async things and these callbacks, so your stack tends to be very short within your callbacks. So it becomes a little complicated to trace an entire stack across different async calls. Some frameworks like Zone.js, if anyone has heard of that, help with that. And they do really complicated hacky stuff to basically say everything is happening within a global context, so I can stitch together an entire view of the world through all of my async calls. So basically at the end of the day, we want a stack trace. If you don't have a stack trace, GTFO. There's literally, we can't help you. There's nothing we're going to do without a stack trace. We just get some random error. Okay, thank you. So let's open up our favorite tool. So we got this thing called Node.js. Has anybody heard of Node.js here? It's my favorite thing. So if we open up Node and we throw an error, so this is the most fundamental, simple way that we can cause an exception. Let's throw an error and we have the string LOL. So what do we get from this? Well, this is really cool. So here we actually have a stack trace of what this error. So we don't just have error LOL, we have the entire stack go all through. We can see the node REPL and all of these things. Obviously, this is not a super useful stack trace because we're not debugging the REPL, but if we were, this would be more obvious. So what do we have here? So the first we start out with the name of the error. So in this case, we literally threw error. This could also be type error, reference error, or any of the other, there's no index error in JavaScript, type error, those types of things. And then we get the message. So this is the message that we send along as LOL. This could be arbitrary. This is the foo is undefined or something like that. And then we have the stack trace that's attached below it. So the stack trace is broken up into frames. So each frame in your stack trace, or each line in the stack trace is a frame, and each of these are a function call. So as you're going through the depth of function calls, you have more and more frames. Each of these frames has a caller. So the caller is the function that occurred at that frame. We have the file of that function. We have a line number, and we have a column number. At this point, things are pretty good. So if we have a stack trace, we have a very detailed view of everything that happened throughout the entire, all the sequence of events that led up to the exception being triggered. So does anybody know what, so if we want to try to get the stack trace from an error object, does anybody know what this would evaluate to?
String.
It is a string. Absolutely, because that makes total sense. Getting a string back when I want to introspect the stack traces. So in V8, so this is very specific for every engine. So in V8, you need a regular expression, something like this. This would parse all of the pieces out of a stack frame. So basically what you need to do is you capture this stack and you walk through each of the lines and you split it up into all its pieces and you say, here's the function, here's the script name, and blah, blah, blah. Note this is very specific to V8.
I think I missed when you explained what V8 was.
Oh, so V8 is the engine that Chrome uses. Also Node uses, and I think Opera uses it now as well. Or is that something different? I don't know. So V8 is just the JavaScript engine. So if we want to kind of apply this to something that's a little more practical than throwing an error inside of our console, we probably have an application like this. So we're doing something really incredible. We're shipping this to our users, and we're making millions of dollars off of this. So we have the console log, and we're trying to index into this things object. We didn't expect showThing to be called with a number 1. We expected it to be called with a string of some index into the object. So we're expecting something like foo or something. So as a result of this, and we can imagine just what's going to happen is we're going to get some, .foo does not exist because the result of the index is undefined. As users, we did not expect this. In our own testing, we ran showThing foo, and we got exactly what we wanted, and we moved on. So if we were to run this in Node, this is what we would get back. So we go back to the stack trace, and we have something that's very, very, very useful at this point. We can actually say inside of awesome.js, line 9, that exact where the cursor is exactly where the error happened. It happened because of that dot. It happened because it raised a type error that said it cannot read the property foo of undefined. That is the best information that you could possibly get. We know exactly where the error is. We can see that, oh, why is foo undefined? We can probably derive some more information like this. And if we also note inside the stack trace, the one that I have bolded is the actual function, the most top frame that was called. So if we look back, that is inside of our showThing, which was line 9 and column 30. In Firefox, we end up with a stack trace that looks something like this. So this is mostly useful, but note that's a different format, so we have to parse this format differently. This also varies differently for versions of Firefox, so that's fun. One thing to note, if you look at this line, there is only a line number. So we get line 9. We don't get a column number. We don't get the cute column number like we got from V8 that says column 30. In Safari, we get something that's more useful than Firefox. We get a line number and a column number. One thing to point out too is that all of these messages are different. They're the exact same error. This one is type error, cannot read property foo of undefined. This is things index is undefined. Undefined is not an object, evaluating, blah, blah, blah. This stuff's just frankly a mess. Like, there's no standardization of what this means, and given an arbitrary string of what the stack is, there's no structure for what this means. So, Humanifies their code when they put it into production. I hope probably almost everybody. So in the real world, this is actually what our awesome.js is going to look like. So we don't have that nice, pretty line 9. We have everything is compressed down and we're back to our line 1. If we also look into this, we don't even have a function called showThing. We have a function n. Hold on. There's a cool feature I can do here. Hold on. Try this. Yeah. N. So n is basically our minified version of showThing. So that's cool. So now what happens when we actually get an exception from this? Well, now it's not as useful. It's sort of useful, you can derive the information because we're working with a really, really tiny script. But if you can imagine, you're building some big thing in Angular and you have 300 kilobytes of JavaScript, it's not going to be as friendly. You're going to have no idea what you're pointing at. Maybe you can dissect it. I've seen Ben do some crazy things in Chrome and figure things out in minified code. But in a source, it's not as useful as it was when it was unminified. But we can't ship our production code. We can't ship our unminified code. We can't do the things. There's performance reasons, security reasons. We want the obfuscation and whatnot. So we have to have some way of dealing with this. So also, if we look at this, we're back to our type error is, or sorry, the culprit is function n. Which, what does n mean at this point? In your minified file, you're probably going to have 100 n's. No idea what that means. And we're at line 1, column 125. What the fuck does that mean? So this brings us to this thing called source maps. So who has seen a source map or used source maps in your code? Thank you. These are super, super, super useful things. So what is a source map? So a source map, its sole job is to map up these minified tokens to what they were in the original source. So that's able to translate this app.min.js line 1, column 125 back to app.js line 9, column 30. So it makes, and then it will inflate that symbol n to the symbol showThing. I'm not going to get into the format of what a source map is because that's pretty terrible as well. But feel free to look into that; it's pretty interesting. But to even be able to use a source map, we have to have 3 critical pieces of information. A source map does not just magically work. We have to have a file number, you have to have a line number, we have to have a column number. So if we go back to kind of what I was saying before, who doesn't give us a column number? Firefox. What are you going to do with a source map? You don't have a column number. So there's nothing we can do about this. There's no way to introspect where in the line of anything is just line 1. Good luck. Column numbers are rare. This is the most difficult piece of information to get out of browsers. All the more modern browsers have done a much better job. It's still the most rare element to get. If we go back to window.on error, the only one that supports it is brand new Firefox and brand new Chrome. They're the only ones that even give you a column number. Everyone else is just going to give you a line number, and at that point you just need to throw it away. So, just pointing out, Firefox only has line numbers, so we notice we have line 9. Yeah, that one's just, have fun. To be fair, someone did point out, like Internet Explorer 11, I think 10 and 11 actually do a pretty good job. Everything before that, terrible. Just have fun. So at the end of the day, what is the problem here? So we have this .stack, we have this Error.prototype.stack thing that we're working with, and we're trying to mess with this blob of string that's different from every single browser. So we have our V8 version, we have our 8 different Firefox versions, and we have to write all these terrible regular expressions to try to extract this information. And at the end of the day, we're probably doing this faulty. We're not, they have to try to map it up with source maps and all this crazy stuff. But this sucks. Like this is not the ideal way that you should be parsing this information or getting something useful out of this. So V8 has introduced this API called this call site API. So it gives you, which is not the best implementation, but you have a global callback of prepare stack trace. So you just set this globally and you say this is how the .stack property should be represented. So the default way is to render a string. So it'll take all the individual frames and all the objects and it'll render out that string that I showed. So the cool thing about this is you can choose not to parse these at all. You can return back the raw list of frames on the call site. And it'll look something like this. So we just set our global, we set our global prepare stack trace, and we just say, or it takes 2 arguments, the error itself, and the frames. In this case, let's just try returning just the frames. We're not going to parse these at all. What happens is we get back this error.stack. And if we look, this error.stack is actually a list that I can inspect. I can take the 0th frame, we take the first frame, and we have these really, really cool functions. We can do get function name, so we don't have to regular expression parse out a function name. We don't have to leave that for a human error for writing a bad pattern or any of that stuff. We can call .get line number, get column number, and many, many other things. This is awesome. So we've kind of identified all the different ways or reasons why an error object is kind of the way we want to go. We have the best result. If we're working with V8, we can deal with these call sites. If we're working with Firefox, we can at least parse the stack traces. At the end of the day, this is an order of magnitude more powerful than a window.on error, where we just get our single line message, which if that's obfuscated through a minification, there's nothing you can do about it. So how do we try to collect these errors and prevent them from getting to a window.on error? The most obvious and simple way is through a try-catch. So we have our try-catch. We want to do stuff, we want to catch our error, and then we want to do something with that error. So at this point, let's just hypothetically log this error somewhere. So let's say we got this error object, that's cool, let's log it. And then just kind of best practice when you're doing these types of things, you want to rethrow it. Because in this case, if we're catching things and we don't necessarily expect there to be an error, this is an unhandled exception. And in this case, we don't know what to do with it, so we want to bubble it back up. So our case of doing this is we explicitly just want to catch it, we want to log it, we want to be nice and rethrow it. That way our application can gracefully fail, we do other things, we just want to get the information before we bubble it back up. Does that make sense? It's a little weird of a topic. Cool. So, but as we can imagine, this approach is not the most scalable thing. We can't wrap every single function call inside of a try-catch. We don't know where these errors are going to happen. That's the point of, that's kind of the point of all this talk. If we know where the error is, we just catch it and we deal with it. Or we fix the bug or we do something like that. So we're trying to catch the bugs that we don't know exist. We're trying to catch the thing that I shipped and Joe found an error tomorrow and he's pissed about it. So we can't predict, and we don't want it to get windowed out on error. So what do we do? So we have to wrap everything. So we got to do this thing, monkey patching, and we want to wrap big blocks of code. We want to say somewhere in this chunk of code, maybe an error will happen. I don't know what's going to happen or what this is going to be, but I want to just catch it somewhere in this stack. So this ends up looking something like this. So in Python land, we have this thing called decorators, which is basically just a function that returns another function. And what this is, we can use this wrap function to wrap any other callable. So any callable that is, or any other function that we're passing around. So if we pass a callback, we can wrap it in this. And what that happens, if we look, this is basically the exact same code that I showed before, but except in a very generic sense. So that would change our code to look something like this. Now we have something, we don't know where the error is going to happen, but somewhere in this stack, our code is going to break. Or maybe break, but we want to make sure that we catch it and we deal with the error and then bubble it up nicely because we didn't know this was going to happen. But at this point, we're now able to capture that the type error that happened there. So this sounds really complicated. This is a very tedious thing. So what we've done with Sentry and Raven is that we basically do all these terrible things. So there's a lot of things that things that we hook into, there are things that we monkey patch that you shouldn't have to worry about. So for example, monkey patching a jQuery Ajax callback. That's a thing, that is a very useful thing to capture because most things are making an XHR request. Most things are calling out to a network service. And then if we capture that block of the callback, that is most of people's code in reality. Or we catch other event listeners and stuff like that we can wrap. We can wrap set timeout.
Monkey patch, what does that mean?
Oh, so monkey patching. So that's basically saying, here's set timeout. So window.set timeout. We want to override window.set_timeout with something else. We want to give it different behavior. So by this, if we go back to, so we go with something like this. Whoa. So if we were to imagine wrap set timeout. So if we did window.set timeout equals wrap set timeout. We've literally overwritten window.set timeout with our own wrapped version of window.set timeout. Does that make sense?
Kind of.
So we're kind of clobbering, we're patching in our own behavior.
If If I search monkey patch, it'll be.
Yes.
Okay.
Yeah, it's very general, just computer engineering term, but yeah, it's the concept of just interjecting your own behavior. It's sketchy because you're potentially
Development only, yeah. It's not for production.
I mean, we do this in production.
Okay.
I mean, that's part of the risk, but that's why we do it. I mean, it's a lot of work to make sure that you don't break things. Like, you don't want to wrap something with faulty code and then your wrapper is what's erroring. Ideally, that's transparent. Another case for monkey patching is maybe I want to get a little better. I can't think of a good example because there's not many good examples for monkey patching. they're usually pretty specific cases, like something like this, but you're literally changing the behavior of something that shouldn't really be changed, if that makes sense. So we can use this and we can abuse this by doing all these things you don't have to think about. So for example, window.setTimeout. This is it sounds kind of innocuous, but at the end of the day, a lot of things are going through window.setTimeout. Other things that you're using, any animation is going through ultimately a window. Well, there's the window animation event thing now, but a lot of things end up going through setTimeout. A lot of things go through an AJAX callback through jQuery. A lot of things go through your event handlers. So if we're able to monkey patch in what that behavior is at that point, we've wrapped everything. Yeah, so we kind of out of the box, we monkey patch native objects and we instrument libraries that allow us to instrument them. So for example, in Angular and Ember, they have everything. You're kind of working within a framework anyways, and these frameworks have this concept of their own exception handling. So you're able to hook into Angular's their own error callback. At that point, we can hook in Raven. So what's happening is they've effectively try-catched all of your code. They've monkey patched all of the things that they need to do, and they catch your errors. So then we can just hook into that and get the error out of that. And then what we do is we take that error object and we're able to parse the stack trace, we're able to get all this useful information out of it, and then what we do is we send it over to our server called Sentry. So Sentry is the name for the actual server. So this is something that you can run on your own, it's an open source thing. And then Raven is the name for all of the clients. So JavaScript is just one of the clients. There's Python, Ruby, literally any language you can think of. There's like Go, Erlang. It's kind of stupid how many different clients we have. And all of them are open source. So some of them are really bad and can use them out. So what happens is we take this and we also will parse your source maps. So how does that work? So if we haven't used a source map, what happens is at the bottom of your minified source file, I don't show that. But basically what happens is at the bottom of your minified source file, there's a little declaration, there's a comment that says where you can find the source map. What we do is we parse the file and we get the error. The error says it happened in app.min.js. We can fetch the app.min.js. We look for a source map. We can fetch the source map. If we have all of the three things that we need, well, obviously we have a file name because we got the error. If we have a line number and a column number, we will go and fetch the source map and we'll try to parse that and give you back the full view. So we end up with an interface like this. So this is something in Sentry that you would see. So if we look here, this is a type error, cannot read property, top of undefined. Here's exactly in our source where it was. And if we look really closely, we can see that it's from a lib.min.js. So we've completely inflated all of the frames in your stack, and we've shown you, all of the bits and pieces that you need. So by looking at this, I can straight up say target.position was undefined at some point. I can dig through the stack and maybe figure out a little bit more information, but at the end of the day, I know exactly what happened. Top was trying to work on something that was undefined. And if you look down here, the original location, it was line 2, column 10,571. I'm not looking through that. So at the end of the day, these tools are, we're doing a lot of work that's unnecessary. So for example, the clients that we use in Python and Ruby are really nice because the language allows us to introspect this data in a really, really nice fashion. We need to make this better. So kind of the problem that I feel that we have with all of these things is that nobody is using these types of tools. Nobody's really trying to introspect these things and aggregate this information and collect this from all of their users and whatnot. They're looking in their browser, they're seeing the stack trace, they're debugging this. Exception handling should be simple. This is a fundamental thing of code. We're going to write code that throws exceptions. We're going to write code that's bad. We're going to have code that does unexpected behaviors. we want to be able to capture this across everything. We don't want to spend or waste QA hours of saying, let's check every browser under the sun. Let's check IE6 through IE11, Firefox, every version they've ever released in Chrome, and Opera, and every phone browser. There's just too much shit out there. It's impossible. And it's a waste of time. I could ship something and instantly see that, oh, so in Sentry, errors will start flowing in. We ship something bad, let's roll it back. All these errors were coming from Opera. Okay, that's, now I can start digging in. Here's the stack trace that came from it and whatnot. I want to help with these things. So I've worked a little bit with, I've posted some bugs on Firefox, and there's not a lot of traction. I don't know too many people that are actually involved in this, but it doesn't seem like there's a lot of attention. So kind of what I hope to get out of sort of working with Sentry and stuff is bringing more exposure to this stuff within JavaScript communities, because this is really a browser problem. So this is not a problem with the language. I mean, people complain about JavaScript, whatnot. I don't really care about Java. Like, JavaScript is fine. Browsers do a really bad job of this. And the problem is that none of the browsers have to converge on standards on this, because nobody is trying to say, let's collect all of these errors and put them in one place. So one of the things that we do is we aggregate errors. So we say the same error that happens, we don't notify you for every single error. We roll it up and say this one error has happened 100 times to 50 different users. It's really hard when all of these messages and stuff are different. So do we need to translate every single one and put them into a specific format? It's a pain in the ass. And then also, if you really get into this, different browsers will give you different stack traces at times. They will point to different column numbers. They'll point to different line numbers. They have a different amount of frames. It's just, I basically hate my life for this. It's pretty, like I said, I'm not a JavaScript developer, so I came into this thinking, oh, this is easy. It was a bad idea. So if anyone's interested in this stuff, here's a couple references. We have Sentry, obviously, which is the server. So I mentioned Raven.js, which is the JavaScript client that collects the errors. You can read that. The source isn't actually too bad. Sentry itself. So this thing we did, is browser stacks. This was fun. We wrote a script that went out to, I don't know, what are those like browser testing tools you can run against millions of browsers? Selenium? No, not Selenium. Like that hosts browser shots and shit like that. We wrote this script that basically did it and ran it on every single browser they had. It threw an error, captured the error, here's the raw data that we get back from an error object. Here are all the properties. And that's just basically a dump of all of these JSON blobs of the things that we collected. It's bad. Like there's some shit in there. A really cool thing to look at is this stack trace JS. It's kind of a different purpose, but it's the same idea. It's collecting stack traces and parsing them. They're all around like printing them out a little bit differently, but it doesn't actually collect them and try to send them to somewhere to log and aggregate. It's a little different purpose, but they do a pretty good job. I mentioned Zone.js. So Zone.js came from one of the AngularJS people, I believe so, or still an Angular person. And what it is basically, it's creating these environments that all of your code runs in. So instead of things getting deleted on error, or things going across multiple async callbacks, it collects all of that together and maintains the whole state. It's pretty wild what they do, and I actually don't understand most of the code. But I would like to steal it. Then that JavaScript stack trace API, which is documenting the format and whatnot of the call site API. So the whole V8 way of being able to actually introspect the frames. So I have some questions, or I have some answers, like potentially answer about this, but really a lot of this stuff is trial and error. Crying myself to sleep. It's pretty bad, but it's a very interesting world. There's a lot of problems, a lot of things that could be made better. So hit me with it.
What about overhead? Like, what's the rate of if you have something that's potentially an error every user's hitting, like Sentry somehow scales, or I don't know, how does it work?
Oh yeah, so that's a really good question. So Sentry, so by itself, we do that by throwing away data, frankly, which is kind of funny. I have another talk that I give that's about like cheating and web scale and stuff, which is kind of talks about that side of things. But we get around it because we throw away data, which sounds bad, but in practice, a lot of data is duplicate. So you say like, oh, if you ship something bad, like something really fundamentally broken that every person is erroring on, you don't really care that it happened a million times.
Yeah.
You care that, oh shit, it's happening now, a lot of people are getting it. and we sample stuff. So you're going to lose some data, but the idea is that nothing is unique. Very rarely are you going to get one error that you care about, and then you happen to lose that one error within the million that happened. It's probably not a big deal. So we frankly throw away your data, and that's fine. No one has ever complained.
Did I hear you correctly when you said we can't test all browsers, so don't invest in creating a test layer? I mean, let it bubble up the exceptions.
In my opinion, yes. Like I think like there's a lot of humans are expensive, right? Like I mean, we all probably get paid a decent amount of salary. Like these are expensive things to have a QA engineer test things. And you're effectively a robot, unless your job is to straight up like you cannot have exceptions, which is the case. I mean, that's a completely different scenario. Most of us are working on some SaaS thing or whatever, and we deploy something, it's a little bit broken, we fix it real quick, and everything's good. There's certain cases where that's more important and QA is more valuable. Like Disqus, frankly, like it's not the end of the world. Like if we have a little, a bug somewhere, oh my god, you can't upvote something. It's not the biggest thing in the world, so it's easier to be able to debug these things post-mortem.
Can't type, just saying.
Disqus? You're saying Disqus is broken?
Oh, sometimes when I'm trying to enter stuff in Disqus on my phone or something, cursors all over the place.
Well,
Anyway.
here's a tip. I don't know JavaScript, so I didn't do that. But yeah, I mean,
if I can comment on that, I used to work with Matt, so I'm going to comment on that. Disqus specifically has invested a lot of time in being able to do really fast rollbacks, within a minute. So and there's a lot of error tracking, so they rely on the philosophy of if something serious happens, they can basically go backwards immediately.
We know, I mean, that's
that
kind
may
of
not be true of a lot of services.
Yeah, so I mean that's one of the benefit of using something like Sentry and whatnot is that you ship something more or less right away. So you instead of letting it be broken overnight and into tomorrow or even for a week and all of a sudden people are contacting support. We have a support team and stuff like that, and a lot of bugs go through support. If it doesn't hit there, we don't know. Something like this gives us insight into as it happens before people are saying that stuff's broken. And then also relying on people giving us useful information so we can reproduce it, because that's usually not the case.
A bit of a new question. Can I run Sentry locally behind my firewall?
Yeah.
Cool.
Yeah, Sentry is completely open source. We have an IRC channel that I can, will help you set it up or whatever. We also, you can pay for it. So pay us money. It basically, a lot of people just, we just want to throw shit and we don't want to, have to.
Do I make the check out to you or?
Yeah, right. Direct donations. Cash.
So you actually have Sentry as a service?
Yeah.
Oh, very nice.
So you could sign up and say, I'm going to pay you, whatever a month, and just, I don't even want to think about it. Which, to be fair, it's actually really cheap, so it's not that big of a deal. But for the people that do have security stuff, or if you're dealing with a really, really large scale, we have Mozilla and stuff, use Sentry, or Disqus as well. We run it internally just because it ends up being cheaper if you're throwing millions and millions of exceptions, because we will charge a lot for that. Yeah, or if you have security reasons why it can't just be thrown over the internet, which is fair. You can just host it yourself.
Cool. Right.
Anything else?
Are there any browsers that Raven.js won't work with?
IE6. Probably IE7. The problem that a lot of the cases that I see is that it technically operates, but if it doesn't give you the right information, it ends up becoming a useless error. So what ends up happening is, for Disqus, for example, we don't send every browser there. We actually explicitly check before we even initialize Sentry, because we only care really about the ones that actually can give us something actionable. We don't care about Opera Mobile, or something like some obscure things that just ends up being noise that they're going to send us garbage that we can't interpret, and at that point we're just, okay, something's broke. I mean, it's good to know maybe that signal, it's something to know that something is broken, but the stack traces itself are not, it's not useful. So we try to do a lot of work of actually filtering out data, which is a big thing that a lot of other people don't do in this space. They don't really try to filter out data. Everyone tries to say, your data is really important, whereas we say, we only want to give you stuff that's actionable. I'm very big on things that are actually actionable. If I see something that's garbage, it's just noise. I want to see something that I can actually take action on and fix. Does that make sense? So if IE6 sends me something that's just script error, what am I going to do about that? Nothing. Log it as a graph is a better option for something like that. You know, just put it, you know, this has happened how many times a second.
Using error stack trace in a browser environment, and then returning a value that's non-string, right? All those frames, the raw frames. Doesn't that cause problems with what the user perceives the stack to be? That would be different across browser environments.
Wait, across browser environments? What do you mean?
So if you set error prepare stack trace, and you do this for every browser, but only in V8 is how you have the stack.
So Raven.js very specifically does not actually use that because there's not because it's basically only supported by Chrome. And at that point, I'd rather just regular expression and parse it because it's a little bit more reliable. If it was everywhere, I would spend more effort to implement that. But at that point, I would just easily check if there is an error.prepare stack trace available, then hook it in. So you can just conditionally deal with that. And then on the side of like that log error function, at that point we check is error.stack a string or is error.stack something? Is it a list? Does that answer the question?
Yeah, I was just worried about what
Oh, like what a user sees?
Yes, the user sees.
I mean, are you talking like what it looks like in the
The
the debug panel? Or?
Sentry, the user is a factor. The developer that chose to use Sentry, they're gonna look at errors in their code, and the stack is going to be a non-string sometimes, string other times.
Oh, you mean if you were outside of Raven did this?
Yes.
So, yeah, I'd be fucked right now. Like, we definitely don't handle like if you were to override this, which is a problem. Like that. So the fact that the API is based on a global, so you have error.prepare stack trace. This is really bad because of things like that. I can't say I want to handle it this way. You want to handle it this way. Someone else wants to handle it this way. A really fun story of that is if you do this in Node. So Node has this really cool thing called CoffeeScript that you can run. So the problem with CoffeeScript is it's compiled to JavaScript. One of the things that it does is it monkey patches this, or it doesn't monkey patch, but it shoves in this prepare stack trace. And what that does is so they can give you their own versions of stack trace that are useful within CoffeeScript. Get out of here. Like, this shit's just terrible. Like, because it's a global thing, we have to be able to detect that, like, you've changed this. Raven, there's a Raven node, too, by the way, and that has some weird shit in it to deal with, literally to deal with CoffeeScript, because...
He wrote that CoffeeScript code.
That code.
Good job. Yeah, that's just terrible. Yeah, so that's part of it. So there's, like... So Angular, is the person that wrote error handling in Angular here too? That's terrible. So that message attribute, so if anyone has debugged Angular and really looked into it, what does Angular do with that? It literally takes the stack trace, shoves it into .message, and they mutate it to do something else. I have no idea because then they also map it up with their online documentation. So they just completely jack up anything that you're trying to do that's useful. They throw their own exceptions and shove their own stack trace in because then they link from their stacks to their documentation, source code, which is kind of a nice idea in theory, but you're just abusing the fact that we're going to shove this in .message because it looks really nice in the debug console. When you open up the console, you see useful information. Now I got to parse that. Like it's bad. I don't think Ember does that, as far as I know. But I know Angular is the biggest one, because in Sentry, for example, we truncate that message, so then people send garbage. And then people do it with Angular, and they just have a truncated message that ends up being useless because, well, they're doing stupid things with their error objects. I don't know why they do that. I don't write JavaScript, but I think it's a really bad idea. Sorry if I offended you about CoffeeScript. Messing with the globals. They're not friendly. I actually don't remember what I do to get around it. Someone submitted a patch that apparently makes it work. I don't use CoffeeScript, so I don't really know. Anything else? Cool. Thank you.